let's get into missing values. When it comes to missing values, replacing the missing value with some logical value is called as imputation. Okay, replacing the missing value with some logical value is called as imputation. We have three different variants of imputation: missing completely at random, missingness at random, missingness not at random. We will first try to understand the differences between these three. Post that, we will talk about a few of the techniques which are used to replace those missing values with some logical value. Replacing the missing values with some logical value is called as imputation. So let's proceed further. First, what are the three variants? Variant number one is missing completely at random. What do you mean by that? For example, say doctor is making a note of various details of different people. And this doctor, okay, suppose, okay, let me allow that table to pop up and then I would stop that. Yep. So say this doctor is trying to record name of the patient, age of the patient, gender, and whether that person smokes or not. If you have less traffic, less number of audience or patients rather who walk in, probably the doctor would fill in all the details. But as in now a lot of people come in, maybe doctor, because of a lot of people walking in, might accidentally forget to take certain details. For example, for this person, Arundhati, gender, probably doctor didn't fill that. Okay, probably doctor did not fill Abhiroop's information on what is the age. Probably for Jennifer, doctor missed out asking this question on whether that person smokes or not. And then Fatima, probably we didn't enter, but maybe for certain people, even if you do not fill whether they are male or female, you can, at a later point of time, update the gender. For Akal, the doctor missed out entering age information. The data pertaining to age wasn't entered. And doctor doesn't have probably a predefined mind frame that he has to purposefully miss out some value, but because a lot of patients were walking in for no reason, he just, accidentally, okay, give me your name. Okay, tell me your age. Okay, do you smoke or not? And then gender, probably that person forgot. Based on the name of the person, you can probably give a rough guess on whether that person is a male or a female. But honestly speaking, in this, if you have a name called Bharani, that's my name, by the way, what would you give as a gender? Okay. I always keep fighting with my parents that, hey, you have given me a name wherein people get confused on whether I'm male or female until they see me or until they talk with me. They're like, no, we have given you name of a star. Thank you so much, but there's a lot of confusion out there. Okay, so if you have a name like my name, obviously people will be a little confused. If you have a name such as Chaitanya, Chaitanya is a name which is given to male as well as female, right? So Kiran also is the same. Yep, absolutely. If you have such names, Kiran, Chaitanya, Bharani, people are like confused. I have to tell to people that, hey, I'm male and female also have the same name. However, this is name of a star. So star cannot be male or female. So both of the genders have this name. Anyways, so the point I'm trying to drive is, if the values are missed out, if the values do not exist, and if it happens for no reason, you cannot, confidently say that, hey, there is a reason why the values are missing. But values are missing for no reason, right? Then you say it is missing completely at random. Doctor did not miss out the values purposefully, but yeah, it so happened that the values got missed out. Then you have something called as missing at random. Missing at random would have some reason. Okay. So when it comes to missing completely at random, you cannot assign a cause on why data are missing is unknown. Okay, cause on why data are missing is unknown. But when it comes to missing at random, the reason why data are missing is known. Okay, the cause or reason why data are missing is kind of known. So cause is known. But cause is known, but not very concrete as such. You know the cause, but you're not 100% confident on whether that's the main reason or not. For example, say doctor is trying to get the data and there's one person who wears a sari and walks to the doctor and doctor asks, hey, do you smoke? Maybe because of the tradition or maybe because of the traditional dress, Jhansi might, these are all fictional characters. I don't have any special hatred or liking towards any character or any name. Okay? These are all just given randomly. Jhansi, for example, doctor asks, hey, what is your age? 26. Of course, you're a female. Doctor makes a note. And doctor asks, do you smoke? Jhansi is like, I'm a very traditional looking person. I wore a traditional dress. Should I say or should I not say? Then Jhansi just smiles and leaves. But doesn't give any answer. So what should the doctor assume there? Does Jhansi smoke or doesn't smoke? Oh my God, doctor is clueless. Value is missing here. Could be that she's wearing a sari, a traditional dress. So probably even if she smokes, she doesn't want to disclose. Maybe because of the cultural issues. Or maybe she doesn't smoke and she might feel that, hey, this is such a silly question to be asked. Maybe. So there are some causes, but with certainty you cannot assign it and say that this value is missing because of this reason. You don't know. You don't quite know. Okay. And then maybe Jennifer walks in. And maybe when it comes to Jennifer, Jennifer is pretty vocal, right? And maybe the moment doctor asks, hey, do you smoke? Jennifer might say, yes, I do. These kind of scenarios where the cause is uncertain. But can be guessed. With some probability, it may not be 100% accurate. In these kind of scenarios, you have missing at random. Then you have missing not at random. When it comes to missing not at random, probably when the physician asks various people on their age, gender, and whether they smoke or not, probably he gets the answer. But maybe in this culture or in this state or in this district or in this location, asking a question on whether women smoke or not is probably prohibitive because of the cultural issues. You cannot afford to ask that. Otherwise, people probably will gang up against you. You don't know. So maybe the doctor might purposefully not ask this question on whether people smoke or not. Purposefully, for a specific reason. So I would say reason is known with certainty. You certainly know that, in this location, doctors are not supposed to ask whether women smoke or not, hence the values are missing. Missing values can either have an empty space like that, or they can have NA values, or they can also have null values. I mean, NULL might be written over there, or maybe you might have NAN. NAN means not a number. Okay, so you might have null value, not a number, NA, whatnot. Here, reason is known with some uncertainty. Or reason is known, sir. Reason is known with uncertainty. Here, reason is unknown. So why the values are missing and missing completely at random, you don't know. Missing at random, yes, reason is known with uncertainty. There'll be some uncertainty. And missing not at random means reason is known on why the value is missing with certainty, you know that. So these are the three variants which we have. If you look at, a student, for example, if suddenly student's relative has expired, or maybe, and you came to know about that, right? So what's happening here? Oh, sorry, you didn't come to know, my bad. Let me take back. Suppose a student did not appear for exam, and student did not appear for the exam because student knows for a fact that student wasn't well prepared. So there is a bright student who studies exceptionally well. Purposefully, the student did not appear for the exam because student didn't want to get a low score. Then that is missing not at random. Purposefully, the bright student did not appear for the exam because student probably wanted to prepare very well and appear for the exam at a later point of time. Missing at random, probably the student did not appear because student wasn't keeping well. You know that a lot of students don't keep well. So somewhat, or maybe student's parents were sick for some reason, right? It's slightly uncertain, but more or less you can, assign a reason for that. If the student met with accident on the way to school, it is completely random. Can you guess upfront on that student might meet with accident and then might not appear for the exam? You don't know. It's completely at random. So you might have certain things completely at random, certain things at random, certain things missing not at random. For example, if you have a very high salary, and in the survey question, if there's a question on what is your annual salary, what is your annual income, then those people who have very high salary might not want to disclose because of safety issues. Maybe their kids might get kidnapped and people might ask for ransom. So they might want to keep the annual income a secret. We don't know, right? So these kind of things are very much required. Okay. So having the knowledge of this will help you perform proper imputation. What do you mean by imputation? Imputation means you replace missing values with some logical value. If the value is missing, you go and, replace that value with some logical value. For example, say there are a few deletion methods. And within the deletion methods, you have some simple strategies to deal with. When it comes to the simple strategies, you have something called as case-wise deletion or list-wise deletion or complete case analysis. Case-wise deletion or list-wise deletion or complete case analysis. Okay. So let's take an example and try to solve that. In this specific data set, you have all these values which are missing. If you don't impute or replace the missing values with any logical value, what will happen? Though you have only one entry missing, the entire row will get deleted. Though a single entry here is missing, the entire row will be deleted. Though a single entry here is missing, the entire row will be deleted. Even if you have a missing value here and here, the entire row would get deleted. Here also the entire row gets deleted. This is called as list-wise deletion or case-wise deletion. Row is also called as a list or a case. Cases, samples, examples, instances, lists, observations all mean the same. Complete case analysis means only if a specific case is complete with all the values, only then would you take that. Only would you take the complete case, otherwise you would not. This is called as a simple strategy because you're not doing anything. You're not replacing the missing value with any logical value. You're just letting it remain as is in the algorithm, and the complete row would get deleted ultimately. This is one simple way. Then you have another deletion method, which is called as pairwise deletion or available case analysis. When it comes to pairwise deletion, what we do is, given this data set, you try to find the correlation between these two columns. So you'll have a correlation for these two because you have the values. You'll have a correlation for these two as well. But when you try to find the correlation between these two values, you'd get an error. You'll get an error. And then when you try to find the correlation between age and gender, you'd have correlation between these two. But between these two, you would not find any correlation. When it comes to gender and smoke, you'll have a correlation between these two, all of these. But when it comes to this, you'll not find a correlation because the value is missing. Using this correlation technique, your pairwise deletion would try to understand what values are missing, and it will just ignore that specific row from analysis. This is very, very similar to complete case analysis, but there, if one value is missing, the complete row is deleted. But here, to understand which row should be deleted, it will find out the correlation analysis. Only if all the columns have the correlation values, that would be considered for further analysis. Otherwise, that row would be deleted. This is less preferred because this includes an additional step of calculating the correlation between all the possible pairs. Instead, if some value is missing, let's delete the entire row. Simple, there ends the story. Having said that, you have a few single imputation techniques, and we have statistical imputation, random imputation, etc. When it comes to statistical imputation, we make use of first moment business decision or measures of central tendency. You make use of measures of central tendency. We have three measures of central tendency, which includes mean, median, and mode. First moment business decision. If you look at this column here, if you take an average of all these available values, say you get 28. And then if you replace the missing values with 28, this is called as mean imputation. Then if you have a column like this, you have all the various values. Okay. You look at how many times each value repeats. And then if you see that this value 0 repeats maximum times, then that would be the mode of this, and you replace this missing value with the mode. If you replace the missing value with the mode, then that would be called as mode imputation. Say you have a column called smoke. 1 means people smoke, 0 means people do not smoke. Here 1 means male, 0 means female, assume, right? Now, given this, if you have a lot of 1s, then 1 would be the mode, and you end up replacing the missing value with the mode. Then say you have another column called income. Out of all these income values, if you observe here, you have a number which is very different or very large in comparison to the other values. If you have a value which is extremely large than the other values, then this would be called as an outlier. If you have outliers in your data set, you might say, hey, if it's an outlier, I might want to delete that. Hold on. What does your 3R technique say? You rectify if that is a mistake, or remove that, or retain that. You either rectify that if there's some mistake, or you remove it completely, or you retain it in your analysis if you feel these kind of high values would appear into the future. So this is an outlier. So given this data set, you might not want to calculate the mean. Instead, you might say, hey, let me calculate the median of this column. When you calculate the median of this column, if you get 3120 as the median, you replace this missing value with the median. Replacing the missing value with median is called as median imputation. Okay. And then we have something called as random imputation. When it comes to random imputation, there are multiple variants associated with that. And one variant is, for example, if you want to take age, and if you want to replace these missing values with some logical value, then you take the minimum value from this, and then you take the maximum value from this. Say the minimum value happens to be 26. and the maximum value happens to be 44. You randomly choose some number within this range, and then you replace the missing value with that logical value. Not logical value, with that random value. You choose some random number, whatever. Random means random. There is no logic there. But you ensure that the random values are chosen between this range, say 32 randomly. So replace these missing values with 32. That's random imputation. Then we have something called as hot deck imputation. What do you do as part of hot deck imputation? Okay. I'm trying to figure out if there is any value which is exactly the same. Okay, let's do this. That's fine. So in hot deck imputation, if there is a value which is missing here. Okay. So what happens is it would traverse from here in the downward direction, and it would try to find an exact match. So the same name, same gender, whether that person smokes or not should be the same, and the income should be the same. It will try to traverse in this direction. And suppose it finds that, hey, this is also employee 4. I mean, the name is the same, employee name. And then if you also have 1 here, for example, then 4 and 4, 1 and 1, 1 and 1, 3120 and 3120. So all the values are matching. Since all the values are matching, you take this 26 and replace here the missing value with 26. This is one variant of hot deck imputation. Okay, this is a variant of imputation. There is another variant of hot deck imputation. And another variant is that it would not just stop at the first match. For example, say in the second variant of hot deck imputation, there are multiple ways of using hot deck imputation. And the second variant is it will keep traversing and say it finds another match, which is exactly the same. 4, 1, and here also say you have 1, and then say you have 3120. So if all the values are same, you choose that. And suppose in the entire data set, you could find 2 rows which are exactly the same as this. Then what you do is, you take those 2 values, which is 26 and 29, and then you take an average of that, which will be what? 55 by 2, which will be 27.5. So if this is the answer, you replace this missing value with 27.5. This is the second variant of hot deck. The first variant is, it will keep looking for a similar kind of a row, and it will stop at the first match, and it will replace this in the place of missing value. So missing value would be 26. Another variant is, it would continue traversing. It will find all the values which are similar, and then it will take an average of these. And that average value would get into this. This happens to be hot deck imputation. Now, assume that after traversing through your entire data set, there was not even a single match. your algorithm could not find even a single row which is exactly the same. Then what happens is you delete, okay, you delete the last column here, whichever is that last column. And then using the remaining columns, try to find a match. Chances are high that you might find a match now. So if a value is missing here, you keep traversing and probably you have 4 here, just as an example, right? Same. 1 and 1, 1 and 1. So whatever is the value that you have here, you put that into this empty position. Even after removing the last column, if you could not find an exact match, then the next column is also deleted. So it's something like, I'm going to delete this as well as this. Then I'm going to try to find a match here. If I were to traverse, yep, there is a match here. Suppose this is 4. 4 and 4. 1 and 1. So whatever you have here, replace it here. This is one way of handling hard-duck imputation. Another way of dealing with hard-duck imputation is that you traverse the complete data set, and if you say find 4 here as well, 4 and 4, 1 and 1, and then you have, say, 2 matches, 1 here and 1 here. So what you do is you take these 2 values, take an average of that, which happens to be 30, and you replace this missing value with 30. So when you write the program, Python program, you will have those options to choose either variant 1 or variant 2. Which variant would you choose is up to you. And then this is all automatically done. You don't manually go and do it. Manual on a pen and paper, we are not doing it, right? We are giving it to Python program, and Python would traverse it. And if there is not even a single match with respect to even a single column, then you randomly impute this missing value with some number. So it will switch back to random imputation. And then the additional challenge with respect to this is, if you use variant 1 with respect to hard-duck imputation, if suppose you have a 4 here and you have an exact match, okay, the disadvantage is that, say this is also 3120, just for our understanding, if you replace this with this, that would introduce a duplicate. So it's not going to bring in any new meaningful information into your data. It'll be the exact column. Exact row. So it doesn't make sense at all. Right? Hence, variant 1 is very seldom used. Usually people use variant 2. When it comes to variant 2, you look at all the rows which are similar and take an average of the values and replace it with the missing value. So in the entire data set, you could find only a single match. So again, it's something like it will be a duplicate, sure. But then after doing this, probably you want to remove the duplicates and see whether your data is duplicate free or not. Right? So, yep, there will be challenges. No technique is foolproof. All right. So remember one thing, friends, we are not manually doing it, so it doesn't matter how large your data set is. It depends on the memory and it performs this. So just to give you a quick glimpse, in complete case analysis, there is no additional calculation which happens. Just if a specific cell value is missing, the entire row gets deleted. However, when it comes to your available or pairwise deletion, the additional step which gets involved is you try to find the correlation between various columns. And wherever you could not find a correlation value, for example, here, correlation between these two would be NA. Correlation between these two also will be NA. That means this value is missing. So if this value is missing, that entire row would be deleted. Since, you could as well use complete case analysis. Why do I need to use this? Yes, point taken. Why do you need to use this? Okay, hence this is not widely used. Then why are we talking about this? Since such a technique exists, we are discussing about this. What if they ask you in interviews, right? From that standpoint. Next, we have something called as regression imputation. We have something called as KNN imputation. And we have something else which is called as iterative imputation. All these three we are going to talk about when we get into our predictive modeling algorithms. When we get into predictive modeling algorithms, that is when we will discuss in detail about regression, KNN, and iteration imputation techniques. We also have something else which is called as multivariate imputation by chained equations, which is called as MICE. MICE is also another technique which can be applied along with your predictive modeling techniques. So yes, a few of the techniques we will discuss once we get into the machine learning algorithms. So this is what we have with respect to missing values. So let me get into the theoretical aspects. And then let's run the code. So let me, come on. Something went wrong and the screen got stuck. Not an issue, I could fix that now, I believe. Server. Get to the missing value imputation part of it. Okay, so let's look into the theory and let's proceed further. Okay, let me. So let's get into the Python programming part and talk more about this. Imputation techniques, anything which you write up the hash is a common. Whether you write multiple hashes or a single hash doesn't matter. And you have the libraries, NumPy, Pandas, etc. And using Pandas library, you're using read_CSV, which is an inbuilt function, and you're giving the complete path of your file along with the name of the file and extension. And then using assignment operator, we are assigning it to an object called df. So we have df now, data frame, which has 310 rows and 10 columns. Columns are also called as features. Or variables or dimensions, etc. And you have 310 observations. Rows, entities, entries, cases, lists, examples, samples, so on and so forth. There are a bunch of other terms which you can give to your rows. So, and when you say df dot means you're going to this entire data set. You're saying, is there any NA value? If yes, show me the summation of that. Go to df. Is there any NA value? If yes, give me the summation of that. And here we have all of these values. So you have multiple columns or variables, and you have the NA values available in each of these rows, each of these columns. Now we have within scikit-learn, which is a machine learning library, within that you have a module called as impute. From that, you're trying to load a specific function called simple imputer. Let me run that. Now we can say simple imputer. If the missing values are NA values, NAN means not a number. This is NumPy. Okay, and then you're saying strategy is equal to mean. That means you want to do a mean imputation. Okay, that is what it means, and we already imported NumPy, so I think it shouldn't create any issue. And you're assigning it to something called as mean imputer. So you're taking this function, you're taking these hyperparameters or parameters, and you're storing it here. And when you say dot fit underscore transform, and whenever you use dot fit underscore transform, when you give the column names, it should have the double square brackets. That's the syntax which needs to be provided. And the result is being converted into a data frame. Rows and then columns. And then you're storing it back to DS. And you're storing it back into the same column. So let me run this. Okay, so if I were to open that, we have salaries, we have all the NA values are replaced now with some number. If you now say, go to salaries, is there any NA value? If yes, show me the summation of that. 0. Earlier, when it comes to salaries, when you looked at the number of missing values, we had 32. Now we have none. Why? Because we applied simple imputer, mean imputation, and we stored that in this. And then when we have done mean imputer.fit transform on this, you have the results very clearly visible. Then we can also perform median imputer. You say simple imputer, missing value is NAN, not a number. Strategy is median. And you're storing these hyperparameters into median imputer. Then when you say median imputer.fit underscore transform, it would transform your column called age. So if I were to go to DF, if I were to go to age, all these missing values would be replaced with some logical value. And then we are storing, not with some logical value, my bad, with the median. You calculate the median of age, and you're replacing the missing values with the median of age. Okay, and then the results are stored back into the same column. If I were to run it now, if I were to open that and show you, yep, all the missing values are replaced with median. And now if you say df of age, is there any NA value? If yes, show me the summation of that. It should say that there are 0. There are no missing values because you already have done the imputation. Now, if I say, let me not take a specific column, let me take the entire data set or entire data frame. Is there any NA value? If yes, show me the summation of that. Oh yeah. So there are quite a few other columns which have missing values, but these two are now imputed, salaries and age. So you don't see any missing value here. When do you perform median imputer technique? When do you apply this? When you have outliers in your data and when you retain those outliers, because you might feel that similar kind of values might appear into the future. Okay, that is when you go with median imputer. Each and every point that I'm talking about here is extremely important, and each and everything are possible interview questions. Then you're going to simple imputer. You're saying missing values. If I have NA values, then apply a strategy which is most frequent. Most frequent means that value which repeats maximum times. And that is nothing but mode imputation. So using assignment operator, we are assigning that to a specific object called mode imputer. Let me store that. And then you're saying mode imputer dot fit underscore transform, and you're trying to apply that on gender, sex. You're going to this column and you're trying to apply this mode imputer, and the results you want to convert that into a data frame, and then you want to store the results back into this column called sex within DF sex. We are trying to do the same thing. We are taking the mode imputer, which is already defined here. We are saying fit underscore transform, do that on marital description. So you have marital description here, you want to fit on that. And you want to convert the results into a data frame and load it back into marital description. If I were to double click on this and look at marital description, you have all these. Now, if you say df dot, is there any null value? If yes, show me the summation of that. We don't have any. Marital description is 0. Salaries and age also happens to be 0. Then we have something called as constant imputer. When it comes to constant imputation technique, you need to define on what do you want to replace the missing values with. If you say that, hey, missing values wherever I have NA in, I want to choose that. This can be put in a single row as well, right? You're saying strategy is constant, means I want all the missing values to be replaced with the same value. And if you say fill the value with F, and if I were to apply this, so I think I selected only M over there. If I were to run that, you have constant imputer. And when you say constant imputer dot fit underscore transform, and if I were to refer to DF, and then if I were to refer to sex here, what would happen? Let's see. And then we are storing the results back into DF of sex, right? So what are the values which are missing here? You have row number 8, row number 11, etc. So let me run this and show you what happens. So if you look at 8, 11, you have F. Why do we have F? Because upfront you are saying that fill the missing values, inane values, with F. Okay, so these are a few imputation techniques which exist. A few other imputation techniques we would certainly talk about when we get into the discussion of algorithms, predictive modeling techniques, or machine learning algorithms. When we get into that, a few of these techniques we will redo.